The METUS Tech Show.
Welcome to the METUS Tech Show, a show for HVAC professionals by HVAC professionals.
The METUS Tech Show.
All right, so Rick, is this your first time in New Orleans?
No, this is not my first time. But we won't talk about the last time.
Oh, boy. Bourbon Street?
I think there was a street named Bourbon in there somewhere.
Yeah, okay. Yeah, I didn't realize, but did you know, I looked up the top 20 fun facts about New Orleans, and they have the longest running bridge in the country or the world. It's 28.3 miles long.
That's a bridge that crosses Lake Pontchartrain?
Yep.
Is that what it is?
Yep.
Interesting.
That's no small lake.
So
No.
having no exit on a highway or a road, that would freak me out. 28 mile stretch, and you got no way of getting off. It's a long way to drive.
Well, the weird part is when you fly in, you fly in over this, you look out and there's a bridge and water, and you think, oh, it's a lake. And then 30 minutes later, you're saying, oh, the lake's still there. Well, this must be the ocean, right?
It's a lake.
Yeah. So flying in was pretty wild. It was my first time in New Orleans. Flying in and seeing all that that swamp, the Everglades, all of that. Really cool stuff.
That's the Mississippi Delta.
Yes. Yeah, a lot of bass fishing.
Yep.
They hold a lot of bass fishing tournaments, bass masters out here and everything. And I'm an avid bass fisherman, as you see from all my pictures
Of course.
on Facebook. But anyway, welcome to the METUS Tech Show. All right, we're going to talk about the Thermostat Interface on this episode, and we have Juan Cardona, technical instructor out of the Ohio Training Center.
Yay.
We got Paul Shaves, technical training manager, a senior technical training manager for METUS.
Howdy.
Myself, Steve Pimentel, technical instructor out of Southborough, and we have a special, very special guest
An honor.
on the show.
This is an honorable person.
Yes.
We're in the presence of greatness.
This is a guy that a lot of us go to.
But is
For-
Steve Jobs here? I thought he passed away.
It's pretty close.
Pretty close.
Yeah.
Pretty close. All right.
You might know more than him.
He's like a sage here at METUS, and we go to him for all of the information that we need.
Yeah.
He's like a second. He's like that second MyLink drive that no one knows about. And when I call this guy for information, I want a quick answer, and he says, Steve, they make something called the service manual. And I say, thanks, Rick.
But there's one thing about Rick. When you ask him something, that's it. There's nowhere else to go. Whatever answer he gives you, it's gospel.
Yep.
Yes.
Right? There are other people you can ask a question like, I'm not so sure. I'm going to ask somebody else. When you ask Rick, there's no one else to ask.
So, Rick Powell, welcome to the METUS Tech Show, and tell us what you do here at METUS.
So that's kind of a hard thing for me to answer, and I struggle with that I hate these things where you have to introduce yourself and say what you do, where you came from, what you've done. I always struggle with that, because I don't know what to say,
Well, on a typical day, what do you do from the moment you get to the office to the moment you leave?
Well, his boss might be listening, so we probably don't want to go through that.
Yeah.
But, Rick, how about this? How about just give us what's on your business card? You give out your business card or your email signature, and what does it say for a title?
Currently, it says engineer,
There we go.
controls for the Tiger team.
All right.
I best describe as what I do is anything and everything that has the word Mitsubishi on it, I will fix it.
Yeah. You're what we consider Tier 3 of support,
I would say Tier 4, right?
Tier 4.
Because we start out with our customer care
That's
center,
right.
And then from there we go to our TSA department,
Yeah.
right? And then from there we go to our ASMs,
Okay, that's right. Yeah.
right? And then from there, where do you go?
Yeah, that's you.
Tiger team.
Yeah.
And then
Tiger
from
team.
there, we go to Rick.
I heard you guys are there to pick the fleas out of the pepper.
What?
Yeah. That's
Does
what the
pepper have
Tiger team
fleas?
does. That was one of his counterparts told me that's their job. When it gets to that tier, this stuff's screwed up, and they need to figure out what's going on. They're there to pick the fleas out of the pepper.
Okay. Well, we're not going to pick the fleas out of the pepper. We're going to bring it down a couple levels. We're going to talk about the thermostat interface. So our equipment comes with different controllers, Mitsubishi controllers, wired controllers, wireless controllers. But when would we use this thermostat interface?
That's a very good question. When the thermostat interface first came out, a lot of people that worked for Mitsubishi and have worked, with this product for a long time was not happy with it because they felt like this was going to take the efficiency of the product away. Mm-hmm. But of course, they didn't realize or didn't understand the way it worked, which is most of the cases, right? In fact, I was very excited because this was a product that could help solve a lot of problems, right? Most people, this has been one of the biggest complaints over the years, is people are used to using their traditional thermostats. And when they look at our thermostat, it's completely different. We don't call it a thermostat. We call it a controller. And they can't get their head wrapped around that. Well, the thermostat interface gave them the ability to have the thermostat they've always looked at, right? Mm-hmm. They could go out and buy any thermostat they wanted, even the old T87 Honeywell thermostat that we all grew up with, or some of us grew up with.
I grew up with it.
Yeah, I know you did.
Yeah.
You probably still have a jar of mercury.
Yeah, I remember the T87F with the Q539 sub base.
Yeah.
Ooh, look at that.
Wow.
Oh, very impressive. So a thermostat closes some contacts, whereas a controller sends ones and zeros to command a system. Basic in a very basic terms, right?
And I think that's what separates the differences. In a thermostat, the system is either on or off, right? In a VRF system with a controller, it's variable speed. It may never turn off. It may throttle down and just kind of idle along, which a lot of people struggle with that in our country, because they think this thing's never turning off. Mm-hmm. And we years back used to say, well, okay, it's not turning off. How does your power bill this year compare to your power bill last year, right? And they said, well, it's half the price. I said, well, why are you worried about whether it's running or not? And currently what I tell people is, when do you get your best gas mileage out of your car, right? Do you get it in town starting and stopping, or do you get it on the highway, right? So VRF equipment is designed to continue to run, but it runs at a very low speed. And that's kind of why we don't label our controllers, and here I go again calling it a controller. This is not the thermostat interface. We don't call them thermostats, we call them controllers, because thermostats, like you say, actually turn the equipment on and off. They don't allow it to keep running. But the thermostat interface, believe it or not, and this is where a lot of people didn't understand, there's a way to keep the unit running and idling instead of turning it off completely with that thermostat interface. Now, you can turn it off completely if you want to. It has that ability as well, but it also has the ability to retain that efficiency by allowing it to run at a very low idle speed continuously rather than turning off. Even though the thermostat contacts may open up and send it a signal, I'm satisfied, it will still keep the unit running, and it'll still monitor the space temp while it's doing that. So in case it does get too cold or too hot while it does continue running, it will eventually turn off if it's overheating or overcooling.
Yeah, so Rick, we discontinued the PAC 444 thermostat interface, and now we rolled out the PAC 445. And that had a lot to do with changing defrost operation for the IntelliHeat coil that we just rolled out as well. Am I correct in saying that?
That is correct. We had to change the code, the way the thermostat interface works. The 444 was excellent, but to bring the IntelliHeat to market and the way that it works, because it is a heat pump with a gas backup heater, what we would call a dual fuel system, right? So you can set up a changeover point at which the heat pump will heat down to a certain temperature, and then once you hit that temperature, the heat pump will turn off and your fossil fuel heater will come on. We've had those for years. It's kind of funny, over the years, gas has always been cheaper than electricity. But I have seen in my career, times when the price of electricity went up or the price of gas went up and met or surpassed the price of fossil fuel. And I've seen people who didn't really like heat pumps actually put heat pumps in to save money. Now, we all know that originally there's a market for everything. And the electrical companies want you to use electricity. The gas companies want you to use gas. So we came out with dual fuel years ago. But now that's what the IntelliHeat is now. And there were some challenges with having our heat pump, which is different than traditional heat pumps. And heat pumps have come a long way, even in the traditional sense. But there are challenges to meet the demands of defrost. To do that, you have to have the compressor run for a certain period of time. And this is true with any heat pump out there. All the basic logic is the same. The compressor has to run for a certain amount of time, and a low temperature has to be met before you get a defrost. The problem with a dual fuel system is you may be running, and the compressor may run half of the time it needs to run to get that defrost cycle. And then all of a sudden you meet that outside temp and you change over to fossil fuel. When you do that, you turn your heat pump off. Well, guess what? That timer that's built in there resets. So you could possibly ice up your coil outside. So what we had to do with the thermostat interface is we had to build in a timer that would allow that heat pump to continue to run after it cycles to make sure we accumulate enough time to have a defrost cycle.
Gotcha. All right. So without the IntelliHeat A coil, let's just look at the thermostat interface as it's basically the thermostat interface, again, was designed so that a customer wants to put a third-party control thermostat, relay-driven thermostat. Maybe it's a Wi-Fi thermostat. They want to use that on a Mitsubishi heat pump system. That's why we're using the thermostat interface. So in that case, they're going to use a 24-volt transformer. That's something they're going to need, either a 5 VA transformer, if they can get away with it, right?
Well, a 5 VA will do for a simple thermostat, right?
Yep.
Now, some of the modern thermostats, and this is one of the things that I like about the thermostat interface is nowadays we have all these big brand thermostats that everybody likes. They're not our thermostats, which is fine, I guess. I mean, the reason we came out with it, right, was so you could use the thermostat of your choice, right? But now you have these Nest thermostats and these Ecobee that people just love.
Yeah.
And this allows them to use that type of thermostat. And those thermostats are Wi-Fi, so they actually have apps, that they can access their units remotely. And I like it because giving people more options is great.
Yeah.
We have our own stuff, and our stuff is fantastic, but allowing them to have what they want is good,
Yeah. And so the PAC 445 is a CN105 device, so we're plugging that into CN105, and then on the other end of the PAC 445, we have our common thermostat wiring designations. So you got your red, your common, W1, W2, Y1, Y2, and green. And there's always this misconception, and I hear it a lot from, it's just the thermostat interface gets a bad rap. Everybody says, well, it takes all the efficiency out of Mitsubishi unit, and it dumbs it down, and it makes a Mitsubishi unit really stupid. What do you have to say about that?
Well, and that's like I said in the beginning. A lot of our internal employees that have worked on Mitsubishi for years were upset when this came out because they thought, oh yeah, like you say, it dumbs it down. It's not going to be as efficient, but that's not true. Like I said, there's built-in features that maintain most if not all of the efficiency that it had before. That you can switch on or switch off.
Right.
To me, it gives you more options to get the comfort that you want as individuals. I mean, we live in our country is different than the rest of the world. The rest of the world pays, and a lot of people don't understand this. We pay usually around 8 to 12 cents a kilowatt hour here.
Mm-hmm.
The rest of the world pays 40 to 45 cents a kilowatt
That's
hour.
right.
So they're not going to run their air conditioners all the time. They're not as fixated on temperature and all that kind of stuff. Whereas we are, we're more spoiled over here.
Yeah, we like our air conditioning also set point down a lot lower than most people in the rest of the world like.
Right.
Yeah, I set my room at the hotel at 65 degrees. So I like to sleep with my covers on.
Yeah, we don't care about that.
Well,
Too much information, Juan.
We're glad that Juan sleeps with his covers on.
Yeah. Okay. All right, let's go. All right. Anyway, thermostat interface.
Yeah. So yeah, like I said, it gets a bad rap, and I think it's just people are not educated enough. Rumors fly, and it does have the setting for variable capacity. Now the PAC 445 is really new for me. I know more of the PAC 444, but in the past with the 444, it was recommended that you use a 2-stage thermostat to get the most out of that Mitsubishi unit. Is that the same with the PAC 445?
It's always recommended to use 2-stage.
Okay.
All right. And that does give you the greatest, and that's like I said, there's so much flexibility with this thing, right? Because you can to get the most efficiency out of it is to use 2-stage, because on stage 1 you're going to run at a very low speed, right? And if you need to get some immediate cooling, immediate heating, which you should never really need, but the fact in our country everybody rolls the thermostat back, right? So when you do that, and I don't know where that came from. If you leave your thermostat off all day long and come home and your house is 95 degrees and all of a sudden you turn your air on, it can take till 3 or 4 o'clock in the morning to cool your house down in the middle of the summer. In that case, you need the full 2-stage, but if you just leave it on, here we get back to the analogy of where do you get your best gas mileage? Running down the highway or stopping and going in the city.
Right.
And you get it better if you leave it on and let it run at that low speed.
Yeah.
If you set it back too far from set point, then everything you save by having it off, you're going to lose trying to make it
Right.
up.
There's no benefit in doing so.
Yeah.
Right. And I don't. That's somebody else's problem that wants to think that way, But it is always better to do 2-stage, right? Yeah. But it does have the flexibility to use a single stage full throttle.
Right.
And to be clear, we're talking about a 2-stage conventional thermostat, not a heat pump thermostat.
That is correct. That is correct.
So we have to think of this thermostat interface a little differently than our normal controllers. When we have a relay-driven thermostat connected to this thermostat interface, we can't have another controller with this thermostat interface. Is that correct?
That is absolutely correct.
Because this thermostat interface, when it turns that system on, it's always sending on commands and keeping it in that mode. So last command wins is out the window. We can't.
That is true. So traditionally, we had a control logic that we all referred to as last command wins. So you could have 5 different control devices on a unit, and whoever issued the last command, that's the command the unit would follow. With the thermostat interface, just by the way that it has to work, it sends constant commands. And even when it's off, it sends a constant off command. So it's not compatible to work with any other control device that we sell. Traditionally, we could use any 2 or 3 controllers that we sell on one unit, and we would be fine. But with this one, you cannot use it with any other. I mean, some you can use certain parts, but in my mind, if you put anything else with it, you're just wasting your money on the other controller. You need to leave it all by itself.
Right. So being from the Northeast, Paul and I, and one, you're in cold climates.
Right.
The rebates that the state offers for dual fuel for setting up your heat pump system so that at a certain outside air temperature, we can shut off the heat pump and run our fossil fuel. Get big incentives in the Northeast for that. You know, a lot of contractors are saying, well, I want to use a thermostat interface and I want to be able to control my boiler and use a thermostat that has a backup heat function. Can they do that?
That, and here again, you know, I say the thermostat interface fixes a lot of stuff. Not necessarily fixes a lot of stuff. It gives you lots of options,
Yes.
right? So until the IntelliHeat, we had no option for like what you're talking about, dual fuel, where you can flip over and get these incentives. Well, actually, with the thermostat interface, yes, you can. You know, because you are dealing with low voltage wiring and relays.
Right.
You can go in and put extra relays and thermostats in, and you can accomplish all that with that simple thermostat interface.
All right. So we have to do a little bit of integrating with relays to get that to work. So there is a way. We have app notes available on my link drive on the thermostat interface that are very in depth. Probably some of it written by you, Rick. Those app notes, some of that logic. I'm sure.
Well, one of the things when the PAC US 444 came out, the first thermostat interface, there was not a lot of knowledge known about how it worked, the sequence of operation. So there was eventually an app note created for that. Now there's actually 2 app notes. And those app notes, I don't do the app notes. Those are done by our applications department. And it came right off of the sequences that the engineers, designers came up with for it.
Yeah. So like I said, there's misconceptions out there, a lot of rumors. Go to my link drive, look at those app notes. They're great. They explain the operation of the thermostat interface. It's really important. Okay. Now, there are dip switches on the PAC 445 that allow you to change function settings, change the way the indoor fan will behave, right? And it comes defaulted at auto mode. One that I want to talk about that I still can't wrap my head around is the defrost delay time, and where it keeps the unit running long enough to meet that defrost prohibit time.
Right.
It's defaulted at 5 minutes on the PAC 444. Now, I remember a story you telling me you had to go to the Northeast or maybe do something with tech support over the phone with a job site in the Northeast, where we were finding out that some heat pumps weren't running long enough to bring in an actual defrost, and we had some units freezing up, and you had to change that delay time from the default 5 minutes to 30 minutes.
Yes, that's correct. And that actually came from Canada.
Okay.
They saw it worse than we did. They actually started to get the outdoor units to freeze up, and they wouldn't defrost. And I worked with them through email and over the phone one winter. And as a solution for that, we changed that 5 minute continuous runtime to the maximum of 30 minutes. And that fixed their problem. It allowed that compressor to run long enough to build up that time it needed to defrost. And that's why that was one of the reasons that major change was done in the PAC US 445. It was for the IntelliHeat, but it was the same problem was going to happen in the IntelliHeat that happened in the original.
What I can't wrap my head around is after reaching thermostat set point, the unit will continue to run according to this dip switch setting and to that time. So if I reach set point and the system runs for an extra 30 minutes, am I maintaining set point? Am I going out of range, or is it just, how does that work?
So what happens is when the contacts open in the thermostat, and this is traditional, right? We have an open or closed contact. The moment that those contacts open and the signal from the thermostat to the thermostat interface is lost, the thermostat interface immediately looks at the return air sensor, which it's already looking at anyway. It sees what that return air sensor temperature is seeing, and now it gives it a set point that's 2 degrees away from that. But it's not really giving it a set point. It's just allowing the compressor to run all the way down to idle speed and just idle along. Now, what will happen is if the room temp gets 2 degrees colder or 2 degrees hotter during that runtime, the unit will cycle off to keep it from. So you could have a 2 degree overshoot in heat or cool during those times. But here again, if everything's sized right, and this is the key thing here, right? And that's why Canada never had a problem when we set that timer to 30 minutes, because normally it's so cold, it's going to run at idle. It's not going to be producing a lot of heat.
Right.
Before that 30 minutes is over, it's going to get another call, and it's going to ramp back up to a higher speed.
In a short period of time.
I get it now. Okay.
Right.
That makes sense. All right. So I think we covered quite a bit and answered a couple of questions that I had on the thermostat interface. And I think this is going to answer a ton of questions for everybody in the field, because this is such a unique controller, right, in the Mitsubishi world, and it's really popular, especially in the Northeast. Everybody's got, I mean, everywhere. Everybody wants. They have Alexa. They have Nest in their home. They have a smart home, smart bulbs, smart everything, and they want to keep their Nests, but they want Mitsubishi inverter technology as well. This is the answer. Right.
And one thing you said that we didn't highlight on about the dip switches. A lot of people don't know that there are dip switches in this PAC US 445. It does require that you take 4 screws out to get the cover off. Now, we've asked, and hopefully one day down the road, the dip switches will be exposed so you don't have to pull the cover to see it. But the dip switches are there. They're there to make these adjustments, but they're also there for ducted units to set your static pressure up.
That's another thing, we didn't mention, right?
And it's also
Good point.
The dip switches are also there to enable your auxiliary heat. A lot of people don't know in our ducted units that do come with auxiliary heat. In order to get that auxiliary heat to work, you have to turn what we call a mode or a function on to enable it.
And that's function 8 and 10, I think?
No, the 8 and 10 is for your static pressure settings.
Okay.
All right. 11 and 23 are for your heat settings.
Okay.
So 11 enables the heat, and 23 allows that heat to work during a defrost or an error in the system. And that is all done by dip switches on the PAC US 445. On a traditional unit of ours, it would be done with a mode setting or a function setting using a MA style controller or an MHK2 style controller. Right. But with the thermostat interface, all of that functionality had to be moved to dip switches.
Interesting.
Yeah. And keep in mind that when you make changes to dip switches like that, you want to cycle power for them to actually take effect.
And that's another thing. We state this, and it should be stated. It can never be overstated enough, is that any change you make should be made with the power off.
Oh, yes, very important.
Even plugging this thing in, you don't want to plug it in hot. Some of our boards actually have fuses on them, and if you plug a device in, like the CN105 connector, if you plug anything into it while it's hot, you could blow the fuse on the board. And these are not replaceable fuses, so you've just killed the board.
Yeah,
so
now you need a board.
Right. So always do things with the power off.
Rick, as always, when I talk to you, I learn something. Right. So thank you for joining us today. And I think we all learned something.
Absolutely. I know I did.
Yeah, definitely. And I'm probably going to forget some of this. I'm going to have to listen to it again.
Yes.
We have it recorded. So fantastic. Rick, again, thanks for joining us, and we'll see you on the next one.
Yeah. All right. Bye, everybody.
Thanks
Adios.
All right. Adios. Adios, muchacho.